Imagine building something. You dedicate years to it, pouring in thousands of hours, literally mountains of data. And when you finally finish the whole shebang, you step back and realize you don't actually know what you just made. Welcome to this explainer. Today, we're taking a journey into the invisible, totally opaque core of the technology that's rapidly running our world. And this isn't science fiction. This is the current reality of the most advanced artificial intelligence on the planet. To really grasp the scale of this, let's look at this wild medical mystery from back in 2016. So, an AI system was analyzing patient data and correctly diagnosed a patient with lung cancer. Naturally, the doctors asked, okay, why? What exactly did the system see? But when they looked for the answer, absolute silence. Neither the machine itself nor the brilliant engineers who programmed it could actually explain how it arrived at that conclusion. The AI was 100% accurate. The patient did, unfortunately, have cancer. But the explanation? It had just vanished into the code. Which forces us to stop and ask this central question of our explainer today. Why? Seriously, how is it mathematically and practically possible that we can build a machine so unbelievably smart, so capable of outperforming human experts, that we fundamentally don't understand how it thinks? Section 1. Defining the black box. What is it exactly? Okay, let's dive right into this engineering concept. So in engineering, there's a specific term for a system where you only get to see the inputs and the outputs, but the intermediate process remains completely unknown. It's called a black box. We've essentially gone through this massive historical shift. Think about the old white box systems, like a standard calculator. You type 7 times 8, it outputs 56. We know the exact, explicit, step-by-step rules it used. If an email says Nigerian prince, send it to spam. It's completely transparent. But modern deep learning, it's a true black box. Instead of giving the machine rules, we feed it millions of examples and just tell it, hey, learn the patterns yourself. It writes its own rules, but in a language we literally cannot read. And the scale of this self-taught logic is just staggering. Modern neural networks don't just use a few rules. They rely on billions of parameters. Imagine billions of tiny math levers, right? All being adjusted independently and simultaneously during training. By the end of it, these billions of numbers produce genius-level behaviors. But nobody, and I mean nobody, knows what role each specific number is playing. Because we can't read those parameters, these systems have a terrifying fragility to them. For example, researchers found that by placing one tiny, simple sticker on a physical stop sign, an autonomous driving system became completely blind to it. It just saw it as a meaningless object. When you don't know the rules the system is using to see the world, changing a single tiny variable can cause the whole illusion to just shatter. Section 2. Our own black box. Now, hearing about these unpredictable machines might make you kind of nervous. But I want to shift the paradigm completely for a second and turn the mirror back on us. Consider this quote. Humans are also black boxes with good public relations. Think about it. Do you know exactly, step by step, neurally, why you prefer your favorite song? Can you map out the exact mathematical pathways you use to instantly spot your mom's face in a crowded room? No way. We make complex, instant decisions constantly without knowing our own neural pathways. Let's break this down with a quick analogy. Picture a master sommelier. Step 1, they taste a wine. Step 2, the brain unconsciously processes hundreds of chemical signals in massive parallel, checking them against thousands of stored memories in mere milliseconds. Step 3, they instantly spit out a verbal reconstruction. Ah, yes, a 2015 Bordeaux with oak notes. But that verbal explanation, it's usually just a post-facto reconstruction. The deep, unconscious processing all happened completely in the dark. As the neuroscientist Antonio Damasio points out, human intuition isn't just magic, and it's not a rational emotion. Intuition is actually compressed reason. It's millions of distilled life experiences acting together in a split second. A veteran doctor knows a patient is crashing within 30 seconds of walking into the room, sensing micropatterns in skin tone before even looking at a chart. Human intuition acts exactly like an AI's deep learning model. We're both black boxes. Section 3. Inside the network. What we do know. Now, what's really interesting is how we map that human concept onto the math hidden inside the AI. A neural network processes information in distinct layers. The first layer might just detect basic edges or textures. The middle layers combine those into complex curves. And then the final layer outputs an abstract concept, like cat. It's kind of like a 1,000-person whisper chain. The first person sees a single pixel and whispers a number to the next. The second transforms it, whispers to the third. If you tap person number 500 on the shoulder and ask what they're saying, they just say, I don't know, I'm just passing along the number 4. Meaning only actually emerges at the very end of the transmission. And yet, researchers probing this massive whisper chain have found some absolutely bizarre things. Deep inside these mathematical networks, they've isolated individual artificial neurons that react only to incredibly specific triggers. We're talking neurons dedicated entirely to human faces, neurons just for text that curves to the right. They even found neurons that only fire up when the system sees dachshunds. Dachshunds? It highlights the absolute absurdity here. Highly specific dachshund neurons, hidden deep inside a sea of billions of numbers. But intervening in this black box is legitimately playing with fire. In a 2023 study, when engineers at Anthropic went into their model and artificially activated certain internal neurons, it created unprompted, deeply disturbing outputs, behaviors that shocked the very engineers who built the thing. Emergent behaviors inside these systems can be terrifyingly unpredictable when we start poking around in the dark. Section 4. Real-world risks, high-stakes failures. Which brings us out of the theoretical math and directly into the real world. Because deploying misunderstood AI in society carries incredibly dangerous consequences. Black boxes have already caused untraceable chaos across major sectors. In medicine, when a radiology AI makes a bad call, doctors can't just surgically fix the code because they don't know what caused the error. In the justice system, the Compass predictive policing algorithm developed emergent racial biases from historical data. Nobody programmed it to be biased. It just happened in the black box. And in finance, algorithmic trading systems reacting to each other caused the 2010 flash crash, wiping out $1 trillion in minutes, and nobody understood why until much later. So the absolutely crucial point here is the massive difference between correct behavior and correct reasons. Think about a student who gets an A+ on a test because they just memorized the answer key from last year versus a student who actually understands the material. An AI might give us the correct behavior by memorizing its training data, but does it have the correct reasons? Does it genuinely understand the problem? Well, we found out the hard way that often they really don't. When the COVID-19 pandemic hit, the context of the entire world shifted overnight. Medical AI models that were highly accurate before the pandemic suddenly started generating completely absurd predictions. Why? Because their internal logic didn't genuinely understand human health. They had just memorized pre-pandemic patterns. So the moment the real world changed, the AI failed catastrophically. Section 5. Seeking transparency. Opening the box. Now, I don't want to just leave you in the dark here. There is a glimmer of hope. The scientific community isn't just accepting this opacity. Enter explainable AI, or XAI. This is a crucial, rapidly growing scientific field entirely dedicated to prying open that black box. The whole goal of XAI is to build tools that force these massive neural networks to show their work. The idea is to make artificial intelligence decision-making transparent, traceable, and ultimately understandable to the humans who actually have to rely on it. But that leaves us with one final, really profound hurdle. The concepts we use every day. Ideas like danger or honesty were designed by and for human minds. A neural network, on the other hand, represents its knowledge in a high-dimensional mathematical space. So I want to leave you with this provocative question. Can we ever truly explain a mathematical space that fundamentally has no human words? It's almost like trying to explain the color red to someone born completely blind. As we keep pushing the boundaries of intelligence, that is the ultimate enigma we have to solve. Thanks for joining me on this explainer. I really hope it leaves you seeing the technology around us in a completely different light.